Hello everyone, welcome back to our channel. Today we are going to revise paper 2 past paper questions from 2016 to 2024, and I will cover all the topics related to chapter 1. Okay, so today our focus will be on chapter 1. Let's start question number 1. A liquid is heated until it boils. Which result shows that liquid in the test tube is pure water? So if you see here that how we will know about the purity of any substance, it is only through its boiling point or through its melting point, because every substance has its own boiling or melting point. So if you see over here, the thermometer reads 100 degrees Celsius, and we already know that the boiling point of the water is 100 degrees Celsius. So option C is correct. Question number 2, a 1 centimeter cube sample of substance X is taken. This is sample 1. X is then converted to a different physical state and 1 centimeter cube of sample is taken. This is sample 2. Sample 2 contains more particles in 1 centimeter cube than sample 1. So now we have two different states of same sample, that is X, substance X, the substance X, we have two different samples. One is sample 1 and one is sample 2, but both are in different states. And now they are saying that sample 2 contains more particles in 1 centimeter cube. What does it mean? It means in any sample that is containing more particles, and they are talking about any state of the matter, then you must need to remember that in solid we have more number of particles in a small volume. So it means anything that is here should be a solid. So if you see the process which will cause the number of the particles increase from sample 1 to sample 2, it is condensation of the gaseous X, right? Because condensation of the gaseous X will give you what? It will give you the solid, right? So that's why solid has more particles in a small volume, 1 centimeter cube. Question number 3. Decane has a freezing point of -30 and a boiling point of 174 degrees Celsius. A small sample of decane is placed in an open beaker in an oven at a temperature of 120 degrees Celsius at atmospheric pressure for 24 hours, right? So we have same atmospheric pressure like the room pressure, and then we have the temperature that is 120, but it is less than the boiling point. So what does it mean? It means that, of course, decane is an organic compound and it is volatile, so it can evaporate, right? So when the temperature is less than the boiling point and you just keep it in an open beaker, of course, the liquid can evaporate. So what is happening here? It evaporates. The option B is correct. Let's see question number 4. Which row about a change of state is correct? Now let's see change of the states: solid to liquid, gas to liquid, solid to gas, liquid and solid. So let's see now about energy change and the process. So when a solid is converted into a liquid, we already know that the solid particles are compact together, right? So when the particles will be moving far apart from each other, the energy is always taken in. Okay, so if you see heat is given out, that means it's wrong. So this option is rejected. Now the gas is converted into a liquid. Gas has moved, the particles are far away from each other, right? So now in the liquid, they are coming close together. So when particles come close together, it means they are trying to make the bond. And when the particles are trying to make the bond, what will happen? They need the energy. So heat is taken, they will give out the energy. So when they will give out the energy, if you see here, it is written, the heat will be taken in. It means it is also wrong. Now let's see, the solid is converted into a gas. Now the particles want to go far away from each other, right? So it means they will take in the heat. It means this option is right. Heat is taken in. Now let's see the process. Is this the same process if you convert the solid into a gas? Yes, it's a sublimation process. Whenever solid is directly converted into a gas, it's a sublimation process. So it means option C is correct. Okay, so you have to see one by one each step and then you can find the correct answer. Question number 5. Gases are separated from liquid air by fractional distillation. So we already know fractional distillation is a process in which liquids are separated from each other. And how they are separated from each other? Through their boiling points. Okay. So the boiling points of 4 gases are shown here. Which gas is both monoatomic and liquid at -200 degrees Celsius? We already know that all noble gases are monoatomic. So we have to see A, B, C can be the right option, right? But D is not it's not a noble gas. So it cannot be either. D option is not right. A, B, C, if we see A, B, C, so -200, it means It's liquid at minus 200, right? So the boiling point should be minus 186, right? Its boiling point should be greater than minus 200. And if you see in negative terms, 186 is greater than minus 200. So it means argon is the right answer, right? Option A. So let's see question number 6. In which state does 1 dm cube of methane contain the most particles? We already have covered these questions that most of the particles in the same volume, at which state it will be? It will always be solid. Solid have more particles in the same volume compared to the liquid and gas. So here, if we can find any solid, yes, we can find the solid word here, D. So it means option D is correct. Now, question number 7, the diagram shows the change of state between a solid, liquid, and a gas. So what does it allow? The diagram is showing the conversion of solid to liquid and then to a gas. In which state, in which change of the state is energy being given out? So now we have to see that when the energy will be given out. So when solid is converted into liquid, we already know that the particles are close together, right, in solid. And when it changed to the liquid, the particles will move a little bit far apart. And when solid changed to a liquid, the particles are moving far apart a little bit. So what does it mean? It means the energy will be taken in. It means the opposite reaction will be the one that will give out the heat. Okay, so it means when gas is converted into liquid or liquid is converted into solid, because now the particles are coming close together when they are becoming solid. So when particles come close together, they release the heat. So option D can be right because 3 and 4 are the options in which the particles are coming more close together, right? So option D is correct. Question number 8. Which row describes the arrangement and motion of particles in a liquid? So let's see about the arrangement and motion of the particles. In liquid, we always have random arrangement of the particles. Okay, so we can see here clearly in A and B, we find the random words. Now let's see about the particles. The particles are touching, or particles, there is a space between particles. No, the particles are usually touching. In liquids, the particles are touching, but in the gases, the particles are far apart. Okay, there is a space. So A option is right. And motion, of course, the motion is slowly in the liquids. So option A is correct. Let's see question number 9. 4 physical changes of ethanol are listed here: condensation, evaporation, freezing, boiling. In which changes do the particles move further apart? So the particles can move further apart only in the gases, right? So we have to see which process is responsible for the formation of a gas. So option number 2, evaporation. Of course, we will get the gas, and the boiling. So it means evaporation and boiling are the right answer. 2 and 4. Where we can find 2 and 4? Yes, option number C. So option number C is correct. Let's see question number 10. Solid X is heated for 600 seconds. The graph showed the heating curve that is obtained. So this is the heating curve. From solid, it is converted into a liquid, then liquid is converted into a gas, right? So what is the melting point of X? We can clearly see here that our solid is here, and now at this point, it is converted into a liquid. So that is the process of melting, right? So what is the temperature here? If you count the boxes, each box is for 10 degrees Celsius, right? So it means 170. 170 is the right answer. So option B is correct at 170. This is the melting point for the X. Question number 11. Substance M is a solid at 30 degrees Celsius. The substance is heated at 80 degrees Celsius and its temperature measures as it's cooled down to room temperature. So here it is a cooling curve, right? At 80, up till 80, the substance was heated, right? And then it was allowed to cool down up till the room temperature, 25, right? So now they are asking between which time the substance M is actually freezing. So if you see the question here, they are already telling you that substance M is a solid at 30. So at 30, it will already be a solid. So any temperature that is above 30, it is already a solid. You cannot choose any temperature that is below 30. So if you see over here, this is 20. You cannot choose this one because at 20, it's already a solid, right? It's already has frozen. So you can choose this option Q2R because at 40, it is a solid. And then you can see it is still a solid after the temperature lower than 40, which is 30, right? So Q2R is the correct option. You cannot choose S and T. Please don't rely only on the graph. Also rely on the information given in your questions. Sometimes the questions give you a particular information, and that is actually the information which will help you to choose the correct answer. Okay. So you have to choose Q and R. Read your questions carefully and then choose the correct option. So B option is correct. Now let's see question number 12. Part of a cooling curve for water is shown here. Okay, now we can see the cooling curve for the water here from 100 to, okay, or whatever, 0 or -4. What is occurring between point X and Y? If you see point X and Y, what's happening here? And X and Y, if you see, it is around 0. And we already know that the freezing point of water is 0, right? So now we can see A, steam is condensing into water. No, because this is the freezing point. It is becoming a solid. So this option is wrong. The temperature of the water is decreasing. Okay, that can be the option. Ice is melting. No, not ice is not melting. Of course, it's 0 degree. But particles are losing heat to the surrounding. Yes, because when the particles come close together, usually because now the gas is converted into a solid. So now particles are coming close together, right? So whenever the particles come close together, you need to remember that there will be always a loss of heat to the surrounding. Okay, because they are trying to make the new bonds, or you can say the force of attraction is formed between them. So there will be a release of the heat. Okay, so option D is correct. Okay, sorry, I did not explain why option B is not right. The temperature of the water is decreasing. No, at 0, if you see X and Y, the temperature is remain constant. If you see, it's a straight line. So there is no decrease in temperature. Okay, so that's why option B is not right. Okay, let's see question number 13. Sodium chloride is a liquid at 900 degrees Celsius. Which row describe the arrangement and the motion of particles in sodium chloride and at 900? So we know sodium chloride is a solid, right? But at 900 now it's a liquid. So we have to talk about the arrangement of particles and motion of particles in terms of liquid. So arrangement of particles will be regular or irregular. Of course, it will be random. Okay, it will be irregular. In liquids, we have the arrangement of particles is random. So C or D option can be correct. Now let's see the motion of the particles. Vibrate about a fixed point. No, it is always in solid. So we are talking about the liquid. So it means it is moving randomly. So option D is correct. I hope you got this point. Question number 14. The diagram shows the arrangement of particles in 3 different physical states of a substance. Okay, so now we have 3 different states. So from the picture, we can easily see state 3 is actually a solid. This state 1 is a liquid and this is a gas, right? So now let's see which statement about the physical states of a substance X is correct. Particles in state 1 vibrate about fixed position. No, that's wrong because it's a liquid, so they cannot vibrate. It's only in state 3, right? Solid. So state 1 changes to state 2 by diffusion. This is state 1. Liquid is changing to gas by diffusion. Wrong. It is changed through evaporation or boiling, right? State 2 changes directly to state 3 by condensation. So state 2, gas is directly converted into a solid through condensation. That is wrong. Condensation, state 2 is converted into state 1, like the gas is converted into liquid, or that is called condensation, right? The substance in stage 3 has a fixed volume. Yes, that option is correct because it has the solids always have a fixed volume, right? So option D is right. Question number 15. In which changes do the particles move further apart? So if you see, the gas is converted into a liquid, liquid is converted into a solid. So whenever you are getting the gas, the particles will move further apart. So which process is explaining the formation of a gas? If you see, liquid to gas, right? And solid to liquid. So it means Z and Y are the right options, right? If you see the arrow, solid is converted into liquid through Z, and then liquid is converted into gas through Y process. So Z and Y are correct. Where we can see Z and Y? Okay, it's D. Option D is correct. Which statement describes sublimation? So sublimation is the process in which the particles, the solid particles is directly converted into a gas, right? So now let's see which process is explaining this one. Particles moving slowly past each other, speed up and move further apart. So which particles move slowly? So it's in liquid. So no, The liquid is not converted into a gas. So this option is wrong. Particles are vibrating. Yes, that is right because solid is converted actually into a gas. So B and C can be right, right? So now let's see, we can read it completely. Particles vibrating next to each other become mobile and move slowly past each other. So they become mobile and move slowly past each other. Again, it's like the solid is converted into a liquid. That is wrong. Particle vibrating next to each other start to move rapidly and move further apart. Yes, in gas, actually, the particles move further apart and very rapidly, right? So because sublimation is the process of conversion of solid into a gas. So this is solid they are talking about, and here they are talking about the gas. So option C is the right option. Question number 17. Oxygen melts at minus 219 and boils at minus 183. At which temperature its oxygen is a liquid? So you have to find a temperature that is less than minus 183, right? So minus 183, which is less than minus 183, but it should be greater than 219. So if you see there, so the boiling minus 183 at minus 183 it boils. So at minus 189 is the correct option. Why? Because in between we have minus 189. 189 is less than 183, right? Because it's a negative sign, so it means that it will be still a liquid at this temperature. So B option is correct. Now let's see question number 18. A mixture of ice and water is left to stand and the ice melts. Which row describe what happens as the ice is melting? So usually when ice and water are left together, you can just remember the process at which now there will be no change in the temperature. Why there will be no change in the temperature? I can show you a graph. Here you can see. Where is that graph? I have, okay, this is the graph, for example. No, not, I think, yeah, this. Okay, if you see this one, no, right here. Okay. So, for example, this is the graph. And at this point, if usually you remember this one, that if, for example, if this is a gas, right, and it is converted into a liquid, what is happening actually at this point? Both things are liquid and gas, right? When the line is straight, it is always there are two states of the matter. It is a gas and also a liquid. And same here, if you can see, it can be a liquid or a solid together. So now when they are talking about, they already have told you that ice and water are together, right? So usually when ice, two states of the matter are together, ice and water, liquid and solid are together. So it means that there will be no change in the temperature. There will be no change in the temperature because because the ice and water, they are helping each other. The temperature of the water is actually helping the ice to melt. So that's why the temperature will remain the same. So option C or D can be right. Okay. Now let's see for energy change. Average kinetic energy of the particles decrease. Our energy is used to overcome attractive forces. Okay. So now the temperature stays the same. So what is the reason behind that? Actually, the temperature stays the same because that temperature, actually the heat is used to break the bonds. Which bonds? Not the covalent bonds, of course. The bonds, the attractive forces between the water molecules. Okay. So there are weak attractive forces between the water molecules. And that is the one which is actually used to overcome so the temperature is actually used there to overcome the attractive forces. Okay. So that's why option D is right. Question number 19. Nitrogen is heated in a balloon and which expands slightly. Which statement about the molecules of nitrogen are correct? So let's see, nitrogen is heated. So always remember, when you increase the temperature of a gas and there is some gas, then the particles will gain more kinetic energy and they will move faster. Okay. A temperature always increase the speed of the particles. So which statement about the molecules of nitrogen are correct? They move further apart. The particles will move further apart. Yes, because the speed has been increased, right? So the gas particles can move further apart. So this option can be right. Option number 2, they move more quickly. Yes, that's also right because it is heated, right? Then they remain in the same distance apart. They remain the same. No, because we have already increased the temperature. So particles are moving far apart. And if you see here, which expands slightly, what does it mean? It means the balloon has expanded. So what does it mean? It means that the distance between the particles also have increased. So option 3 is wrong. Option number 4, their speed remains unchanged. That is wrong because you have heated it. So heat always gives more kinetic energy to the particles. So that's why the speed of the particles will increase. Okay, so the speed of the particles will increase. It means option 3 and option 4 both are wrong. Option 1 and option 2 are right. So where we can see, okay, option number A. So option A is right because option 1 and 2 are right. So now let's see question number 20. The particles of a substance gain energy and change from a regular ordered structure to a disordered structure. Regular order structure, we already know which structure is this. This is actually a solid, right? And then it is converted into a disordered structure with large distance between the particles. So which change of the state is described here? So when the solid is converted into a disordered structure with a large distance, it means they are talking about the gas. So when a solid is converted into a gas, what does it mean? It means the process is actually sublimation. So you need to remember these process, okay? So sublimation is the right answer. Question number 21. A sample of ethanol is left in an open beaker at a room temperature. After 24 hours, no ethanol remains in the beaker. That's simple. Ethanol is a liquid and you left it open in a beaker, so it's a volatile. At room temperature, it will evaporate, right? So can you see any option of evaporate? Yes, C. Option number C, it has evaporated. So option number C is correct. Let's see question number 22. So which process causes the greatest increase in the distance between particles? So if you see which process can cause, it can be melting, it can be boiling, okay, and it can be sublimation. So let's see which option. We have melting and sublimation. So which one is the greatest increase, right? So we have to choose among those which has the greatest increase. So sublimation, of course, because the solid is directly converted into a gas, right? So gas has the greatest increase in the distance. So option D is right. Question number 23. A compound X has a melting point of 71 and a boiling point of 375. Which statement about X is correct? So melting is 71, boiling is 375. So let's see. It is a liquid at 52. So if you see the melting point is 71, right? So how can it be a liquid? After 71, it can be a liquid, right? So can we see any after 70? Yes. So these options, option number C or D can be correct. It is liquid at 75. Yes, it is liquid at 80. So these both options are correct. Now let's see about the gas. And the gas at 350. If you see the boiling point is 375, it means it will be a gas after 375, right? So the 350 is a wrong. So 400 is the correct option. So it means option number D is correct. Let's see question number 24. The diagram shows the arrangement of particles in the three states of matter. Okay, we can see this is solid, this is liquid, this is gas. Solid carbon dioxide, dry ice sublimes to gaseous carbon dioxide. Which row describes the initial and final states? Now, if you see here, we already have, we know that sublimation is a process in which solid is converted into a gas, right? So which one is solid? Of course, R is a solid and P is a gas, right? So R to P. So initial state is R and then we have final state is P. So I think option C is correct. Yes, option C is correct. Now let's see question number 25. Pure water has a boiling point of 100 degrees Celsius and a freezing point of 0 degrees Celsius. Yeah, we already know that. What is the boiling point and freezing point of a sample of aqueous sodium chloride? So now they are saying aqueous sodium chloride, right? So aqueous sodium chloride means the sodium chloride is dissolved in the water. So when it is dissolved in the water, it means they are actually talking about the impurity of the water. Always remember this is an exam tip. Even if you don't get the water or you get any other example, you have to remember whenever there is a question about impurity, you have to remember that the boiling point always increase when there is impurity. Okay, boiling point always decrease and freezing point always decrease. So now let's see the options here. We already know that the pure water has boiling point of 100. So if the boiling point increase, it should be 102, right? So 102 can be the correct option, C or D. So now let's see about the freezing point. I already told you that freezing point or the melting point will always decrease. So can you see here which one has decreased? C. So it means option C is correct. So because it was 0, now it is -2. Clear? So option C is correct. Let's see question number 26. Question number 26. A gas is heated, the pressure is kept constant. Okay, which statement describe the behavior of the particles in the gas? So a gas, we have heated a gas and the pressure is kept constant, right? Which statement describe the behavior of the particles in the gas? The part, of course, the gas is heated, so the particles will move faster, right? The particles will move faster. Yes, that is also right. The particles will move slowly. That is wrong. So it means the option A or B can be right. Now let's see the other option. The particles move faster and become close together. No, whenever the particles will move faster, of course, the distance between them will increase. So it means the option A is wrong. So we are only left with option B. The particles move faster and become further apart. Yes, option B is the right answer. Okay, now let's see question number 27. A gas is in a sealed container with a fixed volume. Which statement describe what happens to the molecules in the gas when the temperature is increased? Okay, so we already have a gas in a sealed container and that has a fixed volume. So if you increase the temperature, I already told you whenever we increase the temperature, what will happen? The particles will gain more kinetic energy, right? And they will be colliding more often. So they move more slowly. Oh, that's wrong now because the temperature is already increased. Okay. Now let's see number 2. So one is wrong. They collide with the walls of the container more frequently. Yes, it's right because the temperature has been increased. So now the particles will move more faster, right? So they will collide with the walls of the container. Option 3, they collide with the walls of the container with less force. That's wrong now because the particles have more kinetic energy, so they will collide more frequently with more force. Number 4, they have greater kinetic energy. Yes, whenever you increase the temperature, it will increase the kinetic energy. So it means option 2 and option 4 are right. Okay, so they collide with the walls of the container more frequently and they have greater kinetic energy. 2 and 4. Okay, the option number D is correct. Let's see question number 28. The pressure of a sample of gas is decreased. The temperature is kept constant. Okay, so which row describe the effect on the particles? Now temperature is kept constant. Okay, and the pressure of the sample of the gas is decreased. When you decrease the pressure, okay, what will happen actually? Now the particles will have more distance, right? So let's see about the movements of the particles. The movements of the particles will be slower or there will be no change in the speed. What will happen? Speed always depend on the temperature, right? Because temperature is actually increasing the kinetic energy. So there will be no change in the speed. C and D can be right. Now let's see about the collision between particles. Now the collision between the particles, because the temperature is constant, so it is constant, right? But you have decreased the pressure also. So now the pressure has been decreased. So now the particles have more distance. So they will collide less often. Okay. So where we can see less often and no change in speed. So yes. So option number C is right. Occur, the collision will be less often and there will be no change in the speed of the movement of the particles. Question number 29. A sample of a gas occupies 340 centimeter cube at room temperature and pressure. The temperature and pressure are both increased, but the volume occupied by the gas remains 340. Okay, which will describe what happens to the particle speed and the average distance between the particles in the gas when the temperature and the pressure are both increased. Okay, so now you are increasing the temperature also and also the pressure. But if you see here, what did they say? The volume occupied by the gas remains same. It means that the particle speed or the distance. So what does it mean? The distance will remain the same because it did not change. It did not change the volume. If you see, the volume is still the same. So it means the distance remain the same, right? So it means the distance remain unchanged. So option A, option C can be right. Now let's see about the particle speed. You have increased the temperature. So of course, when you increase the temperature, the particle speed will increase. So particle speed is increased, but the distance will remain unchanged, right? So option C is right. So you have to connect the dots. Temperature will always increase the speed of the particles. And now we increase the pressure. So what pressure is actually now helping the particles to come close together. That's why you can see the distance between the particles is not changing. The temperature is trying to change the distance between the particles, but pressure is now exerting the force so that the particles can come close together. So they are balancing each other. That's why you cannot see any distance between the particles. Okay, there is no distance between the particles, is unchanged, but speed will be increased. Why increased? Because the temperature has been increased. So now let's come to question number 30. A gas is placed in a sealed container. The gas has a pressure of 1 atmosphere and temperature of 50. Okay. It is heated to 100 degrees Celsius. So now we again heat the gas. So let's see now. Which row describe the cause of a pressure of the gas and the effect of increasing the temperature of a gas? So now we increase the temperature. So what will happen? The cause of the gas pressure and the effect of increasing. So first of all, let's see for the increasing temperature, because we already know that the collisions are always more, right? Collision become less frequent. That is wrong. The average speed of the gas particle increases. Yes, that is right. Collision become less frequent. Okay, it means option B and D are right. Okay, the particles. Now let's come toward the gas. Because we have not changed the pressure, right? So what will happen? The collision between the gas particles. Yes, there is a collision between the gas particles, right? But this option, because we already have rejected A and C. So now let's see here. B, collision between the gas particles, collision between gas particles and the container. Okay, so now because there is no change in the atmospheric pressure, right? So now the particles are not coming close together. So what are they doing actually? When you increase the temperature, they will just try to collide with the walls of the container. So option D. Option D is right, because the collision is between the gas particles and the container, not between the gas particles. Why not between the gas particles? Because the gas particles, we are not increasing the pressure. So if you increase the pressure, then the gas particles will come close together and they will collide with each other. Okay, so option D is correct. Question number 31. Particles moving very slowly from an area of high concentration to an area of low concentration. So now this is about diffusion. Whenever the particles move randomly from high to lower concentration, that is called diffusion, right? We are explaining the process of diffusion. So, but the particles are moving very slowly, and we already know that the diffusion only happens in liquid and gas. So, if the particles are moving slowly, it means it is in liquid, okay? If they are moving faster, then it is in a gas. So, option diffusing, yes, and through a liquid. So, option C is correct. Let's see question number 32. A student investigated the diffusion of ammonia gas and hydrogen chloride gas. Okay, two sets of apparatus were set up as shown at room temperature and pressure. The damp red litmus paper in apparatus 1 changed color after 30 seconds. So if you see ammonia gas over here, right? So diffusion is related to that of the molecular weight or molecular mass of any substance. So if you see ammonia and HCl, the mass of ammonia is less compared to that of HCl. So that's why ammonia is just getting 30 seconds. What does it mean? So ammonia is lighter, so it will move faster, right? So it will diffuse faster. But HCl has a higher mass. So what does it mean? If you have a higher mass, then of course, for example, if a fat boy and a slim guy is running, who will run faster? Of course, a slim guy, right? So that is the same case here. Ammonia gas has a light weight, right? So it will diffuse faster. So if it is taking 30 seconds, it means HCl will take more time. So if you see here, 21 is wrong. 30 is also wrong because they don't have the same mass, right? So B, C is wrong. So A is the only correct option. 64 seconds, okay? Because HCl is double, almost the double of the mass of the ammonia. So that's why option A is correct. So if you want to know that why ammonia, how we have calculated the mass, of course, you will be given the periodic table in your exam. So you can calculate the mass of ammonia and also HCl, okay? In exam if you don't know. So it will help you to get the correct answers. So let's see question number 33. The rate of the diffusion of two gases, methane and ethene, is measured using the apparatus here. Which gas diffuses faster and why? Same question. Now they want to know about the diffusion of the which gas can diffuse faster. I already told you that the diffusion depends on what? Diffusion depends on the mass. So the mass is more, you will diffuse slowly. So methane, let's see here. Of course, methane has only one carbon here, but ethene has two carbons. So it means methane can have a lower mass, right? So methane will diffuse faster. So which gas diffuse faster? Methane, of course. C and D can be right. Now let's see the option, the reason. Methane molecules are lighter and so move faster. Yes. So that is the correct option because methane molecules are lighter, so they will move faster. Now let's see the second option. Methane molecules are smaller, so they can get out of the small hole more easily. No, it has nothing to do with the molecules are smaller or bigger. It has the molecules, the diffusion depends on the weight of the molecules. Okay, so molecules are lighter. That's why they will move faster. So option C is right. Question number 34. Small crystals of purple KMNO4 and orange K2Cr2O7 were placed at the center of separate petri dishes filled with agar jelly. They were left to stand under the same physical conditions. After some time, the color of each substance has spread out as shown. So dish 1 KMNO4, it has spread more, whereas K2Cr2O7 has spread less. Okay. So the length of the arrow indicates the relative distance traveled by the particles of each substance. Which statement is correct? So you can simply see from here that KMNO4 has a lower mass, right? That's why it is diffusing more quickly, right? At the same time, it has covered more distance compared to that of K2Cr2O7. So now let's see the option. Diffusion is faster in dish 1. Yes, that's right. Okay, let's see. Diffusion is faster in dish 2. No, that's wrong. Diffusion is slower in dish 1. No, that's wrong. Diffusion is slower in dish 2. Yes, that's right. So it means the first option and the D option can be right. Now let's see the reasoning. Diffusion is faster in dish 1 because the mass of particles is greater. That is wrong. Diffusion is always faster when the mass is less. Okay, they are indirectly proportional to each other. So it means option A is wrong. So we are only left with option D. So option D is right. How? Diffusion is slower in dish 2. Why? Because the mass of the particle is greater. Yes. Question number 35. Okay, we already get the answer, but let's see. I will explain it. The diagram show an experiment to demonstrate diffusion, right? We can see same ammonia and HCl. Which statement explain why the ring of ammonium chloride appears as shown here? So if you see the ring of ammonia is close to HCl, right? So let's see, ammonia solution only produces a gas which moves until it meets the hydrochloric acid. What did they say? Ammonia solution only produces a gas. That's wrong. Ammonia solution is not only producing a gas, they both are reacting and then they are producing a gas, right? Both solution produce a gas. Yes, that's right. But ammonia moves quicker than the hydrogen chloride because it is lighter. Yes, because it is lighter, ammonia is lighter. That's why it is moving more quicker than hydrogen chloride. Okay, let's see now the third option for just for explanation. HCl produce, hydrochloric acid produce hydrogen chloride, which stays at one end of the tube until the ammonia reaches it. That's wrong because HCl, hydrochloric acid will also produce HCl, and that is also a gas. So, of course, it will also move, right? So, that's wrong. The two solutions run along the tube until they meet. Yes, that's right. The two solutions run along the tube. But we are talking about why ammonia chloride is produced here, right? So the best option is B. Let's see question number 36. Which gas diffuses the most slowly? So which gas diffuses the most slowly? For that, we have to calculate the molecular mass of all these gases, right? And the molecular mass of carbon dioxide is more as compared to that of all these other options. That's why carbon dioxide will diffuse the slowest one. Okay, diffuse more slowly. Now let's see, a gas is released at point X in the apparatus shown here. Which gas turns the damn universal indicated paper red most quickly? So it means who can change the color of the litmus paper quickly? Only the gas which has the lowest molecular weight, right? So we have to calculate the molecular weight of all these, and we will see that ammonia has the lowest molecular weight compared to chlorine, HCl, and sulfur dioxide. So it will diffuse or it will change the color of the red paper quickly compared to other gases, okay? The rate of the diffusion of a gas depends on its molecular mass. You see, they already have told you that it depends on its molecular mass and also the temperature. Now, which combination of molecular mass and the temperature gives the slowest rate of diffusion? Now, you need a slowest rate of diffusion. What does it mean? That the molecular mass should be higher, right? When you have high molecular mass, the rate of diffusion will be lower. So A and B can be right because the molecular mass is higher. Now let's see about the temperature. So if you increase the temperature, the diffusion will be more. But if you decrease the temperature, the diffusion will be less. So we are actually looking at the slowest diffusion rate, right? So it means the temperature should decrease. So which option can be right? Option B. So low temperature and high molecular mass will cause a slowest rate of diffusion. Now let's see question number 39. Which gas has the fastest rate of diffusion? So if you see here again, we have to find the molecular mass of all these substances, right? So when you find the molecular mass of these substances, you will find that which one has the lowest molecular weight. Option B, C2H6, okay? So C2H6 has the lowest, ethane has the lowest molecular weight. So that's why the rate of diffusion will be fastest. Okay, so how I know that C2H6? Of course, we have to calculate from the periodic table. The periodic table will be given to you, so you can just find it from the periodic table. You just quickly calculate them, and then you can find that which one has the highest molecular weight or the lowest molecular weight. If it has the lowest molecular weight, then it has the fastest rate of diffusion. Okay, so B is the correct answer. Now let's see another question about the diffusion. Which gas has the fastest rate of diffusion? These are now different. Okay, H2. This is simple because we know that hydrogen has the lowest molecular weight. So A is the correct option. You don't need to calculate it. Let's see another question. Oxygen and fluorine are gaseous elements next to each other. In the periodic table, under the same condition of the temperature and pressure, oxygen diffuses dash than fluorine because its dash is less than that of the fluorine. Okay, now we see if you open the periodic table, you will see oxygen come first before, come earlier than the fluorine. Okay, so it means the mass of the oxygen is less as compared to that of the fluorine, right? So it means if the mass is less, then it will diffuse. Sorry. So it will diffuse faster, right? So oxygen diffuses faster. So option A or B can be right. Then fluorine, because its dash is less than that of fluorine. What it depends actually, the diffusion depends on the molecular mass, right? That's why option A is right. It will diffuse faster because the molecular mass is less than the fluorine. Okay, option A is correct. Now let's see question number 42. Which statement about diffusion are correct? Aqueous ion cannot diffuse in water. That's wrong. Whenever ionic compounds are dissolved in the water, they produce ions. Okay, so they are diffusing actually in the water. So that option is wrong. Diffusion is caused by the random movement of particles. Yes, that's right. Diffusion is always caused by the random movement of the particles. And what happens to the particle? They spread out in all direction in diffusion. Yes, that's also right. Diffusion can only take place in solid and liquid. That is wrong. It only takes place in liquids and gas, not in solids. Okay. So option 2 and 3 are right. Where we can see option 2 and 3. Okay. Option number C. Yes, correct. Option number C. I can see so many students are replying me with very correct options. Yeah, you guys are right. So we are just going through. I think you guys are understanding the topic. So let's see now question number 43. A gas jar of bromine vapor and a gas jar of air are set up as shown here. Okay, now this is again a process of diffusion. We remove the gas light and now you see they are mixed together. Both the gases are mixed together. So now which statement explain why the bromine and air mix together? If you see the color of the bromine is light now, what does it mean? It means some of the movement is actually random, yeah, right? The diffusion of the particles is actually random. So this one is actually explaining the process of diffusion. So can we see anything here? Bromine is denser than air, bromine is lighter than air, bromine molecules move upwards and molecules in the air move downwards. Molecules in bromine and air move randomly. Yes, that option is right. Option number D, because this process is actually about diffusion. And what is diffusion? It's the random movement of the particles. So option D is correct. Whenever you are confused about for example, in some of the options here, then you have to choose the best option, okay? And you have to see actually what they are actually asking about. If you see here, they are actually asking about the diffusion process, right? because two gases are mixing together. So your answer should be related to the diffusion. That's why I choose the option D. Okay. So question number 44. Which statement explain why ammonia gas diffuses at a faster rate than HCl? Why? Of course, it has a lower mass, right? So now let's see. Ammonia expands to occupy all the space of volume. Ammonia has a smaller relative molecular mass than hydrogen chloride. Of course, this is the right option. Always diffusion depends on the molecular mass. So B option is correct. Question number 45. Which gas has the lowest rate of diffusion at room temperature and pressure? So now we can see here the gas produced when ammonium chloride is heated with aqueous sodium hydroxide. So when these two will react, we'll get an ammonia gas, okay? So ammonia gas mass, you have to find. Then the gas which makes up approximately 78% of the clean dry air. Which gas is that? That is nitrogen. Okay, you have to find the mass of nitrogen gas, N2, okay? The gas produced when sodium carbonate is added to dilute HCl. So what you will get here, you will get carbon dioxide. Now let's see the gas produced when zinc is added to dilute sulfuric acid. You will get hydrogen here. So now we have which gases here? Ammonia, nitrogen, carbon dioxide, and hydrogen. So they are asking about the lowest rate of diffusion. So the lowest rate of diffusion is of the gas that is carbon dioxide. Why carbon dioxide? Because if you calculate the mass of the carbon dioxide, it will be less, it will be more than nitrogen, also hydrogen gas, and also ammonia gas. Okay, so C option is the right. 46. Which two gases will diffuse at the same rate and at the same temperature? So we have same temperature now, the temperature is kept constant. So which two gases? So it means these two gases should have the same molecular mass. So if you calculate the mass of all these, you will find that nitrogen, because nitrogen is usually diatomic molecule, right? N2. So it also have a 28, and carbon monoxide also have 28 molecular weight. So that's why option B is right. Carbon monoxide and nitrogen have the same mass. So that's why they will diffuse at the same rate. Question number 47. The diagram shows the result of dropping a purple crystal into water. Okay, so this is also a process of diffusion, or we can say dissolving. Usually in our terms, we say dissolving whenever you are dissolving a solid in a liquid, but we can also call it diffusion, because if you see, the color has changed, okay? And this is not a chemical reaction, because if you see, the color has been changed and the crystal is just dissolved in the water. So which process takes place in this experiment? Chemical reaction? No, of course not. So C and D are right. So let's see about diffusing. Yes, this is a diffusing process. And what about dissolving? Yes, this is also a dissolving process. We can call it dissolving or diffusing. So option D is correct. Okay, I already told you diffusion don't take place in solids, but this is the solution is actually your liquid, right? So it takes place in liquid, but not in solid. Okay, liquid solid, it can take place together if you have one compound is liquid and the other one is solid, but both of them, if they are solid, then it will not take place. Okay, so that's why option D is right. Let's see question number 48. An experiment is set up as shown here. Okay, after several minutes, a white ring of ammonium chloride appears as shown here. So which statement explains the observation after several minutes? Okay, so now we can see HCl is here, and we get the ammonium chloride near the HCl. What does it mean? It means ammonia has diffused faster here. And when HCl was coming, it was coming slowly. So we see the ammonium chloride ring here near the HCl, because HCl diffuses slower as compared to that of ammonia. So our product is formed near the HCl. So now let's see here. Ammonia gas diffuses faster. Yes, that's right. Ammonia gas diffuses faster. That is also right. So option A and B are right. Option C and D are wrong, because you say ammonia gas diffuses slower, right? So these two options are wrong. So now let's see A and B, which option is the best. Ammonia gas diffuses faster than HCl because its molecules have a lower molecular mass. Yes, that's right. It is diffusing faster as a lower molecular mass. That's why option A is correct. Okay. Let's see question number 49. The apparatus shown is set up after 20 minutes. A ring of ammonium chloride is seen at position Y, right? So which statement about the molecules of ammonia and hydrogen chloride is correct? Now let's see. Molecules in ammonia have a larger molecular mass than the molecules of hydrogen chloride. That's wrong, because if you see, The ammonia has a lower molecular mass. If you calculate from the periodic table, it has a lower molecular mass. So A option is wrong. Option B is also wrong because they are again saying ammonia has a larger. So option C or D can be right. Molecules in ammonia have smaller MR, right? Molecules in ammonia have smaller MR than the molecules of hydrogen chloride. Okay, and so they move more slowly. So that's wrong. If the molecules have the smaller MR or relative molecular mass, then they will diffuse faster. They will move more quickly. So that's why option D is right. Okay, so option D is correct. Let's see question number 50. Aqueous lead nitrate and aqueous potassium iodide are added to a dish container containing water as shown. Okay, so a yellow precipitate forms after a few minutes. So which process occurs before the precipitates form? So before the formation of the precipitates, actually, all this aqueous lead nitrate and aqueous potassium iodide was dissolved in the water, right? And this process of dissolving is actually what? Diffusion. So that's why option A is right. Okay. Samples of four gases are released in a room temperature at the same time. These gases are carbon dioxide, HCl, H2S, and NO2. Which gas diffused the fastest? So for fastest, again, we have to look at the periodic table and we have to find the mass of these gases. So if you find the mass, you will see that hydrogen sulfide has the lowest molecular mass as compared to that of the carbon dioxide, HCl, and nitrogen oxide. Okay, that's why option C is correct. Question number 52. The rate of diffusion of three gases of ammonia, carbon dioxide, and methane is measured. What is the order of the rate of diffusion of the gas from the slowest to the fastest? Okay, slowest. Which gas will diffuse slower? Of course, the gas which has the highest molecular weight. So compared to CH4, NH3, and carbon dioxide, of course, carbon dioxide has the highest molecular weight. So option A or B can be right. Okay, now let's see. After carbon dioxide, we have ammonia and CH4. Ammonia has, if you compare the mass of ammonia and CH4, of course, ammonia has more molecular mass as compared to that of the methane. So that's why carbon dioxide slower, nitrogen faster, and then the CH4 methane is the fastest one. Okay, so option A is right. Question number 53. Hydrogen chloride gas HCl reacts with ammonia gas NH3 to form solid ammonium chloride. The apparatus is set up as shown here. So after a few minutes, a white cloud of solid ammonium chloride forms where the two gases meet. So the two gases meet near the hydrogen chloride, right? So now this experiment is repeated again. Ammonia is same here, but hydrogen chloride is changed with hydrogen bromide. And if you see, the bromine comes after the chlorine in the periodic table. So it means the mass of the hydrogen bromide is more than the HCl. So if the HCl can come up till here, then HBr maybe cannot even come up till here. It will be more slower. So it maybe stays up till A, right? If you see, the ring is near the B, but this HBr can come approximately up till A. So ammonia will be coming close together. So maybe we can see the ring at the A, not at the B, right? So what is the correct answer? The correct answer is A. We can see the ring at the A because HBr will be moving more slowly as compared to the HCl. So it will stays closer to this part, HBr. So question number 54, ammonia gas is reacted. Again, the same question, solid ammonium chloride is produced, right? We can see here. Which statement explain why the solid ammonium chloride is formed near to the hydrogen chloride? Why it formed near to the hydrogen chloride? So first, ammonia solution is a base and hydrogen chloride is a no, of course, this question is all related to the diffusion. So we have to find any question that is related to diffusion. So hydrogen ammonium chloride diffuse more slowly than that's wrong. Hydrogen chloride has a greater molecular mass than the ammonia. Yes, that's right. Hydrogen chloride has a higher molecular mass than that of the ammonia. And that's why it's, see, you can see that it is diffusing slowly. So actually this statement, option C, is actually talking about, is showing more relativity to the diffusion process. So option C is right. Brownian motion is not the part of our syllabus. So I think next time you will not get any option related to the Brownian motion. Question number 55. Which statement about the rate of the diffusion of gas, ammonia, carbon dioxide, nitrogen, and oxygen are correct? Okay. So, which statements about the rate of the diffusion of gases? Nitrogen and carbon monoxide will diffuse at the same rate. Oxygen, no. Nitrogen and carbon, yes. I think nitrogen and carbon dioxide have the same molecular mass. You have to calculate, okay? Then you will know it. And the second is oxygen will diffuse slowest because it's an element, whereas the others are compound. That's wrong. It's not dependent upon which one is element or which one is a compound. It's only depend upon the mass. Okay, so option 2 cannot be right. Ammonia will diffuse fastest. So we have to see who will diffuse fastest. You can find the relative mass of these all these substances, and then you will know that which one diffuse fastest. So of course ammonia has the lower mass, so that's why option 3 and option 1 are right. That's why the correct option is B. So how you will know that B option is correct? Don't rely on the option B. You can calculate yourself the molecular mass, and then you will see that option B will be correct. Okay, so you have to do the calculation by looking at the periodic table. For all the diffusion questions, if they are comparing any gases, you have to find the molecular mass. The lower the molecular mass, the faster the diffusion rate will be. Question number 56. 4 experiments, each containing a different acidic gas, are set up as shown. The dividing gas plates are removed at the same time. In which set of apparatus does the litmus turn red first? So which will change the litmus red paper red? So one has carbon dioxide, the other one is HCl, one is nitrogen dioxide, and the fourth one is SO2. So again, you have to find the molecular mass, and you will find that HCl has the lowest molecular mass compared to all these other gases. So B option is right.